sketch the sine and cosine graph. So today I'm going to talk about how to solve for sine and cosine functions. Well, if you can see, well, it feels very hard to read. You can have your light off. Yeah. Okay. That's good. So this is a normal sine graph. Okay, this is a normal sine x graph, y equals to sine x. And if I want to find sine x equals to a half, well, first of all, I will cut this into separate period. Okay, so that's one period. I'll just cut it into period. So that's one period. So they are all one period. So I also solve for sine x equals to a half. So I know where is a half. I will draw a line y equals to a half, which is here. And what we can see is in every period there are two intersections. Okay, every period there are two intersections. And also for this intersection, okay, so this intersection to this intersection, you can see, well, you can see from this graph, that's the distance of a period. Okay, that's the distance of a period. And from this intersection to this intersection, it will be the distance of a period as well. But like I can't really see any relationship between those two. Well, say, I mean, the relationship is like about period, nothing to do with the period for those two solutions. So what all I can know here is if I can find out any two solutions within a period, I can keep adding periods onto that to reach all the rest of it, and I can keep subtracting period down to get the left-hand side solutions as well. So if I can get two, like two adjacent one, like the two within one period, I can get all the rest. Okay, I can get all the rest. So that's the key idea to solve for sine and cosine graph. So it's always, well, choose like this. Well, if that's not a sine x graph, I know the period is 2 pi here. But even though it's not a sine x, say sine 2x graph, I still have two solutions in each period. And then the distance between this one and this one will still be one period. Okay, still be one period. So any two solutions will get period apart, like one period apart. So the key point is to find those two. Okay, is to find those two. So write something down here first. If sine something equals to a, okay, we need to have two, well, I call this like a basic or base solutions, but I need two basic solutions. Okay, which means this one and this one, like I need two because I know in every period there are two, so I need to find out two solutions. But if a equals to +1 or -1, we only need one solution. Okay, we only need one solution. Y equals to 1 or -1 only need one solution. Because if you can sketch the line sine something equals to 1 or sine something equals to -1, you can see those two lines. In each period, there's only one intersection. See that? There's only one intersection. So for sine x equals to 1 or sine x equals to -1, in every period I can only find out one solution. So that's why we only need one solution to start with. Okay, to start with. All the other value include 0. Okay, include 0, you will have two solutions. because you can see y equals to 0 in each period. I can find out this one and this one. I still need two solutions, but you know in one period, like 0 to 360 degrees, only 90 degree can give you sine 90 equals to 1. There's no other values. So in each period, there's only one value can give you 1 or -1. So that's something you need to remember first. Then let's move to the next page. Let's solve for this cosine one. Well, for this cosine one, let's change the period, change the domain. The domain is not good. Change the domain to minus pi on 3 to 2 pi on 3. Okay, change the period to minus pi on 3 and to 2 pi on 3. The domain is a little bit too large, waste of time. I just want to show you the method. Okay, so to solve any sine or cosine graph, what you need to do is to make cosine on one side. So you will have minus a half. Okay, minus the 1 and divide by 2, so we have the minus a half. So I have a minus here. Okay, I have a minus here, but it's alright. What I want to think about is the ratio of half. You think about what reference angle can give you a half. Okay, cosine what equals to a half, everyone? Cosine what equals to a half? Pi over pi over 3. Okay, good. Pi over 3. So we have cosine pi over 3 equals to a half. So the reference angle needs to be pi over 3. I know, well, the angle can't be pi over 3 because pi over 3 give you a half. But the reference angle will be a half. So, okay, I'm interested in what this angle must be. Cosine what can give you negative a half? That's what I want to think about. So for cosine x, well, which two quadrants give you cosine negative? Angle must be in which two quadrants? 2 and 3. Okay, 2 and 3. C is here, A is here. Must be the other two quadrants give you cosine negative. Also, I need a reference angle of pi on 3. Okay, I need a reference angle of pi on 3. So the angle must be here and here. Right, I got the reference angle of pi on 3. Okay, so this angle will change the reference angle and I put the negative into the front. That's how I can get the negative a half. Therefore, the actual angle is this one. That's 2 pi over 3. And then the other angle, the second one is here. That's 4 pi over 3. Well, I normally don't want to go for negative. I want to just look at the angle in between 0 to 2 pi. So I take angle in between 0 to 2 pi. So the first one is 2 pi on 3 and the second one is 4 pi on 3. Therefore, I have find out my two solutions. So I will solve 3x minus pi over 3 will equals to 2 pi over 3, or it will be 4 pi over 3. Then 3x, and then so for x, 3x will be pi and 5 pi over 3. Then x will be pi over 3 and 5 pi over 9. Okay, figure out that, well, I treat everything in the bracket as a one angle, and cosine what give you negative a half. That's the only thing you need to figure out. After you find out that, you just solve for x. Okay, just solve for x. After you solve for x, well, what's those two value means? Those two values are the value, those two. Okay, are those two values in one period. Now the next thing, if I want to achieve all the rest of the angle, I need to find out the period. Okay, period equals to 2 pi over 3. Okay, period is 2 pi over 3. And then the next thing will be talk about the general solution. Okay, I don't think you have learned general solution in year 11. So general solution is something can represent every single solution. Okay, so list out every, not listing, like use some expression to show all these solutions. So you know your first answer keep adding or subtracting period will reach all the rest. So my x will be pi over 3 plus 2 pi over 3 times k, and it also be 5 pi over 9 plus 2 pi over 3 times k. And those two equations are the general solution. Not finished, you must write k belongs to z. Okay, everything here is the general solution, like it's a general solution. What this solution represents? It represents the first answer adding period. Well, k can be what? Can be 1, 2, 3, 4. Like add 1 period, add 2 period, add 3 period. What k also can be 0, not adding anything. Can be negative 1, negative 2, negative 3. Subtract 1 period, 2 periods, 3 periods. So it can give you all the value on the right hand side and all the value on the left hand side. So same logic here. Okay, so this one adding period and subtracting period. That give you the general solution. You change k value to anything, you will get all the solutions for you, like 1, 2, 3 go infinity. So it shows you all these solutions. That's called a general solution. On the calculator, it will give you general solution if you not restrict the domain. Okay, if you not restrict the domain, you will have general solution in the calculator. If I want to see the value in between negative pi on 3 and 2 pi on 3, you must restrict the domain. Okay, so for calculation, because I don't want general solution in this question, like general solution is just a middle step to help me to get my final answer. What I actually want is the x value in between those range, those domain, and satisfy the equation as well. So I will try different k values to achieve those things within the domain. Denominator. For my general solution, I'll make a common denominator easy for me to substitute. So that will be pi plus 2 pi k over 3. And the second one is 5 pi plus 6 pi k over 9. Okay, don't forget the k belongs to z. Very important. If you don't write k belongs to z, you lose the mark. Okay, if you don't write it, you lose the mark. So k belongs to z, you must write that. Okay, now is the trial and error. Well, it's not really trial and error. Like you put different k values to make to get values in between that domain. So I will start with k equals to 0. Okay, that's where I start. Make k equals to 0. So x will be pi over 3 and 5 pi over 9. Okay, let's make a denominator here. That's a negative 3 pi over 9, and that is a 6 pi over 9. Okay, so that's this. Well, you can see it's still within the domain, no problem with the domain. And I can try the next one. I can see it probably will go out of the domain because there's a 5 pi over 9 already. And what I can get is 6 pi over 9. It's a 5 pi already. So the next one might out of the domain, but I'll just show you what I should do. So I try 1. I got, that's a 1. So that's a 2, that's a pi. And I put 1 here, that's a 11 pi over 9. Well, obviously those two are out of the domain, so there's no need of keep doing for k equals to 2, k equals to 3. It's already out of the domain. So I can also try k equals to -1, go backwards. Well, you better write things within the order, -1, 0, and 1, because the number will be in the decreasing or increasing order. Like it will be in particular order for you. So k equals to -1. I got -pi/3 and -pi/9. Okay, put -1 in. That's -pi/3 and that's -pi/9. Okay, see this the most left hand side one is touch the domain already, so there's no need for me to keep trying for -2, like definitely outside, because that's the domain already. Okay, that's the domain already. So there's no need of trying the next. And also you can see my solutions are in the increasing order. Therefore, I make the conclusion x equals to -pi/3, -pi/9, pi/3, and 5pi/9. That's it. So 4 solutions. Okay, 4 solutions. Questions? Okay, I want you to write something down. Okay, write just for question number 4. Copy the same thing, sine 2x minus pi/3 that equals to 0. And x belongs to minus pi to 2 pi. Not 0, no 0, 1. No, 2. Okay, 2. Okay, I want you to try that later by yourself. I'm not going to keep going because you can see this sine will equals to 1. This is the one solution case. In every period, there's only one solution. So you can try that one by yourself later. But I want to move to something really important now. Is some special type of solving circular functions. That's the question. Okay. So let's have a look at the next page. Well, next page about solving the following equations, but this one is not like a pure sine x or pure cos x or tangent x. It's not something only contains sine, cosine, and tangent. So for the first one, it contains sine and cosine together. For the second one, I have sine square and sine. For the third one, I have tangent square. And for the fourth one, I have sine square and cos together, like in one question. There are 4 types of questions here. Well, B and C can kind of belongs to the same type, but A and D is another type. So just don't give you time to think about it. Like, I'll just tell you the answer. So sine and cosine, if you have single sine, single cosine appear in the same question, I will divide the cosine to make it into a tangent. So I would divide cosine 3x on both sides of the equation. Then the question becomes a tangent 3x equals to minus root 3. And I'm solving tangent, like it's a single tangent now. Okay, I'm solving for a single tangent. Okay, I haven't learned tangent yet. We'll skip that first and we'll come back to that later. B, okay. B is, we have sine squared and sine. Okay, I have sine squared and sine. So the thing contains the variable x. one is the square of another one. Remember when we learned exponential e to the power of 2x plus ex minus 5 equals to 0, something like that. We set a. Okay, let a equals to sine x. Because one is the square of the other one, we make the smaller one change the variable to a. So what I'll have is 2a squared minus a equals to 0. And what I'll have is 2a minus 1 equals to 0. So what I'll get is a equals to 0 or a equals to half. Okay, a equals to 0 or a equals to half. So now the question becomes to sine x equals to 0 or sine x equals to half. You're trying to solve for that. Okay, we have like two really simple questions here. Okay, well, you can keep doing after that. I'll skip there. And for 3, well, I have just 10 square in it. I just have 10 square in it. Well, you can change it to a letter b. Let's say b equals to 10x. So what I'll have is 3b squared minus 1 equals to 0. So b squared equals to 1 over 3. b equals to plus minus square root 1 over 3. And that is root 3 over 3. And that's root 3 over 3. So the question becomes tangent x equals to root 3 over 3 or tangent x equals to minus root 3 over 3. Well, it have like two equations now. Create two equations for you. Okay, the last type is we have a sine squared and a cos, or a cos squared and a sine. In this case, I'll use the Pythagorean identity. Okay, I'll use the Pythagorean identity because sine squared will be 1 minus cos squared x. Because sine squared plus cos squared give you 1. So now I can change everything to the same type, like all change to cosine or all change to sine. So what I'll have here is 1 minus cos squared x plus 3 cos x minus 3 equals to 0. And it back to type number 2. So let c equals to cosine x. What I have is 1 minus c squared plus 3c minus 3 equals to 0. 2 minus 2c squared plus 3c minus 3 equals to 0. 2, that's a minus 1. That's 2c squared minus 3c plus 1 equals to 0. Okay, minus everything. And I have 2c minus 1, c minus 1. Equals to 0. So I have c equals to half or c equals to 1. So solve for cosine x equals to half or cosine x equals to 1. I'm solving between those two equations. but not keep going with that, you can just deal with the rest by yourself. So like that's the 3 type of questions what you can do. We have a single sine, single cosine, we make it into a tangent. We have the same type of like sine square and sine, cosine square and cosine, tangent square and tangent. We change the variable to make into a quadratic basically, and then solve for the new variable and then put it back to circular functions. And the third type is you have sine squared and the cos, or cos squared and the sine. We use Pythagorean identity to change everything back to step number 2 and then keep solving. Okay, that's the special solving questions here. All right. Any questions for circular function solving? Yes? Yeah, you just solve for x. The question is asking for x. The x domain is given there. So you just keep working from that. Okay, next one. Next one is talk about tangent functions. Okay, talk about tangent. Okay, tangent function. So this is tangent x. Okay, this is y equals to tangent x. Well, you know that there's asymptotes because there's some value undefined. Okay, what I want, I'm not going to go through all the things again, but like the key thing is, what's the first 2 asymptotes around the y-axis? This one is y equals to minus pi on 2, and this one is x equals to pi on 2. Okay, that's the first 2 because I'll use those 2 asymptotes later. So remember, the first 2 asymptotes around the y-axis will be those 2 asymptotes. Okay, pi on 2 and minus pi on 2. Well, you know what's the rest? Well, the next one will be adding pi onto that. That's 3 pi on 2. Okay, that's 3 pi on 2. So, okay. First of all, there's asymptotes, and the distance between adjacent is equal, which is equals to period. Okay, so the 2 adjacent asymptotes, the distance is a period. So that's 1 period. Why that's 1 period? Well, everything is get the same distance apart, and that's the period. So in between 2 asymptotes, that will be 1 period. And you can see the period for tangent is pi. Okay, period for the tangent is pi. It's not 2 pi. It's not like sine cosine is 2 pi. It's just pi. Point of inflection occurs halfway between the asymptotes. Okay, point of inflection occurs halfway between the asymptotes. Alright, let's talk about how to sketch for it. Let's talk about how to sketch for it. Okay, I will write down the steps for you here. So the first step is sketch y equals to c. That's where the point of inflection exists. Where c value is the constant you add at the back. Y equals to c. That's where is the point of inflection. That's where the point of inflection occurs. Okay, so that's the point. Second, find 2 asymptotes first. Yeah, that's the second. Find 2 asymptotes first. I'll tell you how to find it later, but that's the second step. Number 3, label the point of inflection. Halfway between the asymptotes. Okay, halfway between the asymptotes. So label the point of inflection. Number 4 is look at the A value and N value. A and N. Okay, you look at the A value and N value. What are they? A is the value you times in front of the tangent, and N is the coefficient of x. You look at those 2 values. If both negative or both positive, you have increasing graph. One positive, one negative, you have decreasing graph. And you can sketch after that. Okay, so that's the 4 steps you need to have for sketching tangent function. Okay, so sketch tangent function. So let's have a look at this one. Let's look at example 2. Example 2, which one's easier? Let's see 2. Let's see 2. Okay, for example 2, first of all, I'll label the kind of the middle, which is -3. Just to remind myself where's the point of inflection. Point of inflection will be on this line. Second is to find asymptotes. Okay, to find asymptotes. How to find asymptotes? As I said, the first 2 asymptotes for tangent x is pi(2) and negative pi(2). Okay, that's the 2 values you can't get. pi(2) and negative pi(2). So what I will do here is I'll make the bracket, the angle equals to pi(2) and minus pi(2). You know that's the 2 value you can't get. Right? You can't get pi(2) and minus pi(2). So I want to see what x give you pi(2) and minus pi(2). So I can see the x equals to 1 here, and the x equals to -1 here. Which means what? Your x can't be 1, can't be -1. Okay, can't be 1, can't be -1. So my first step is label those 2. That's my first 2 asymptotes. Okay, that's the first 2 asymptotes. Make it equals what? On purpose, make the angle equals to pi(2) and minus pi(2) to see what's the x I can't get, and that's my first 2 asymptotes. After that, I can see, again, can you see what's the distance between those 2 asymptotes? That's 2, right? That's 2. So the period is 2. Okay, so the period is 2. And then the next asymptotes must be at 3. Because every two asymptotes will get the same distance apart. And the next one will be 5. And you have -3. And x equals to -5. So that's how I can find out all the asymptotes within the domain. I just need to find 2. Okay, I just find the first 2, and then all the rest can be measured from the same distance and labeled. And I will know where's all my point of inflection as well. All my point of inflection will be in between the 2 asymptotes, like in the middle of 2 asymptotes and on this blue line. That's where my point of inflection. I have labeled all my point of inflection now. Well, I don't really need this blue line. You can just get rid of it. Okay, I don't really need it. And the next thing is to decide whether it's an increasing graph or whether it's a decreasing graph. Okay, whether it's an increasing graph or whether it's a decreasing graph. Do you think it's increasing or decreasing? Decreasing, because -3 here, but positive 0.2 here. So it's a decreasing graph. Okay, it's a decreasing graph. So the scale is not very good, so the shape looks a little bit weird. But like that's the decreasing shape, and also point of inflection at the right place, and have the correct asymptotes. Well, better label the point of inflection. So it's 4, -3, 2, -3, 0, -3, -2, -3, and -4, -3. Also, I can see x-intercept, right? I can see x-intercept. There are x-intercept and y-intercept. Y-intercept is labeled, which has 0, -3. I can see x-intercept as well. So I need to work out the x-intercept. Okay, I need to work out the x-intercept. So how to solve for tangent? Okay, let's put it here. -3 tangent pi on 2x -3. I want to make that equals to 0. I want to make that equals to 0 because I'm solving for y-intercept, x-intercept. So tangent pi on 2x is just equals to -1. Okay, 3 divided by -3, that's -1. And can you see? I draw a horizontal line. In every period, it can only touch once. Okay, there's only one solution in every period. So if I can find one, I can keep adding the period to get all the rest. So what you should know is tangent x equals to a. Tangent something equals to a. Only need one solution. Okay, only need one basic solution. You don't need to solve for like 2 for sine and cosine. It's much easier compared to sine and cosine. Now what I want to think about is tangent what equals to 1. Okay, tangent what will give you the ratio 1. So we know tangent pi 4 will give me the ratio 1. But I need -1. Okay, I need -1. So the negative, you need to decide the correct domain. Okay, you need to decide the correct domain for that. Okay, for tangent, because I only need one solution, I don't need 2. I don't need the bottom 2 quadrant. I just need to decide between the first quadrant or the second quadrant. Like I don't need 2, so I just need to, well, this one will be +10. This one will be -10. So, well, first quadrant will give you positive, second quadrant will give you negative already. So I need a -1. It must be in the second quadrant with a reference angle of pi/4 because I want the ratio 1. Okay, I want the ratio 1. So it must be in the second quadrant. Then the angle, the actual angle will be this one, which is a 3π/4. So pi onto x equals to 3π/4. That's the first solution. Okay, that's the first solution. So x equals to 3π/4 times 2/pi. X is 3/2. Okay, x is 3/2. Also, I know the tangent period equals to pi/n. Okay, equals to pi/n. So for this one, that equals to pi times 2/pi, and that's 2. Okay, so period equals to 2 for this one. Also, you can see from the graph. Okay, also you can see from the graph. Pi/n is the domain, is the period for tangent. 2π/n is the period for sine and cosine, which is different. Okay, which is different. So the general solution I can write is x equals to 3/2 plus 2k, where k belongs to z. Okay, the first solution plus period times k, where k can be 1, 2, 3, 4, 5, 0, -1, -2, -3, -4, -5. Like changing, adding one or more period. So I have k equals to 0. My x is just 3/2. But I can make the domain becomes that's a 3 plus 4k/2, where k belongs to z. Make the calculation easier. My domain is -5 to 5. Okay, my domain is -5 to 5. So I want k equals to 0. X is a 3/2. K equals to 1. X equals to 7/2. While still within the domain. K equals to 2. X equals to 11/2. 8 plus 3 is 11/2. That's out of the domain. Okay, that's out of the domain. 5.5. Like, I'm not going to try 3. So I'll go for k equals to -1. X equals to -1/2. K equals to -2. X equals to -5/2. K equals to -3. X equals to -9/2. 3 minus 12 is -9/2. 4.5. I'm not going to have another one. Okay, it will go out of the domain because it's only 0.5 away from the restricted domain. So these are the values for the x-intercept. Okay, for the x-intercept. So we can see this point -9/2 over comma 0. This point -5/2 comma 0. This one -1/2 comma 0. This one is 3/2 comma 0, and this one is 7/2 comma 0. And it's cracked. I can see it's cracked. That's the 5x intercept. Okay, that's the 5x intercept. Good. Now that's a complete graph. We have XY intercept, we have point of reflection labeled, and I have all the asymptotes labeled. That's the tangent graph. Okay, that's the tangent graph. Tangent is much easier compared to sine and cosine. It's much easier. First of all, when you sketch, you just need to figure out the asymptotes basically. When you figure out asymptotes, everything's done. Second, when I solve for tangent, I only need to worry about one value. Only I need to worry about the value in between 0 to 180 degrees. Because 0 to 90 will give you the positive, 90 to 180 will definitely give you negative. So it's enough to just look at the first two quadrants. And it's easy to solve. Any questions? Well, it's basically I just quickly go through everything, like revise for you. You need to do questions, okay? You need to try questions and complete the homework. So I want you to finish everything before page 14. Okay, complete everything before page 14 tonight. Okay, really need to do work and catch up, and I'll keep moving tomorrow. I'll keep going for applications a little bit. Not much left. I have completed all the important things today, so tomorrow is a little bit left. You need to do work. So I have about 15 minutes. I want you to use the 15 minutes to go through all the solving and sketching if you haven't completed yesterday.